I have to wait till I see the screen so I can make sure we're not. Oh, it is set for off. Okay. I'm in this. Okie dokie.
We are apparently now live.
Yeah. Okay. Hi, I'm Meta Spencer, and we're going to talk about building materials today. But don't go away. Don't go. It sounds boring, but I tell you, it's a fascinating topic if you're worried about global warming. Because, I've been wanting for a year now to have another conversation with somebody about how to build our buildings, new houses and high rise and so on, with materials that do not, warm the planet. And I have here two guys who know a thing or two about that. In Vancouver, you are in Vancouver, aren't you, Michael? Mm-hmm. Michael Barnard is a man of many parts. I wouldn't even dare to try to describe him because he has so many interests, but he's very techy, and he can spout numbers very well. And he's going to talk about construction materials such as heat pumps and concrete. I don't know what else. And here in Toronto is Paul Dowsett, who has made a whole career as a special architect of sustainable buildings. And he's also on the steering committee of Project Save the World, which I am always eager to get more people to be aware of. So you should pay attention to us. Hi, Paul. How are you?
I'm terrific, Meta. Thank you so much. How are you today?
Very well. And Michael, how are you out in Vancouver?
I'm good, suffering from hay fever with the pollen counts, but that does mean that I get all the blossoms.
Oh, I got a little snotty nose too. Okay, here we are. Nice to see you. Okay, now I don't know how we're going to start this, but I think maybe I'll ask Michael, who's got a weird looking thing behind him. I understand that's the building you're working on. And it rotates, and you told me last time those green lines are lines of sight where people can see each other, and which is meant to foster community, a spirit of community among people inhabiting that building, right?
Yes, I'm working with Bruce Hayden, and Pete Atkinson, the principals of Human Studio Urban Design and Architecture out here in BC, and collaborators from North America, Europe, and Australia on a project, and with Liz Dunn, Professor Liz Dunn of the Happy Lab at UBC, to create more sociable buildings in the design stage.
But this may actually connect with something that Paul is doing, where I think in St. Jamestown, Paul is doing something that has some social element too. Is that right, Paul? That you're also looking at things like resilience and solidarity and things like that.
All those things, exactly, Meta. So yeah, the work that we're just beginning in St. Jamestown is looking at climate emergency preparedness amongst the residents of the 19 apartment towers that comprise St. Jamestown. And what we understand and what we realize from research around the world is that the very first requirement is social cohesion. If there's social connectivity between people in the towers, then the outcomes of preparedness for climate emergency will be much better.
Okay, so you guys may have some, I expect you'll have something to say to each other, but let's start off with the hardware first, shall we? Look at the construction materials, and if we drift over to the social side, that's okay with me. I'm a sociologist.
Can I start with sharing a screen to set a thesis?
Sure, okay.
Just find the screen, there it is. Paul and I'll go back with different pictures. Part of my thing is that I came from this, which was, this is the British Columbia efficiency in new buildings space. I was looking at this a couple of years ago at a conference, people were presenting on it, and I had an allergic reaction to it, specifically the net zero new construction. The principle of net zero at the time, and this is a geographical perspective and also a legacy perspective. The first perspective is that I live in the lower mainland of British Columbia, which has some of the worst solar power generation capability on new buildings in the world. We just aren't a great place to put solar on rooftops. And so,
I mean, because you get too much rain.
it's rains and clouds, just cuts down, and we're moderately far north, so it just cuts down on the amount of sunshine that we can use to generate electricity. And net
Right.
zero implies that not only do you have a passive home, but you're generating the electricity on site, or a passive building, but generating the electricity on site. And I don't think that makes a lot of sense. And more to the point, I think it makes very little sense out of suburban sprawl models. I'm strongly an urbanist. I'm strongly for more urban density. And it doesn't make sense to try and generate all the electricity a city uses, all the energy a city uses in the confines of that city, when cities take up less than 2% of the land mass of the world. Wind farms interspersed with farmland, just fine. Solar utility scale farms can be put on non-arable land, just fine. It doesn't make sense for me to generate electricity locally. And then the second piece, does it make sense to conserve electricity closely, is the next part of the thesis. And if all the electricity is generated from wind and sunshine, and it's all very low carbon, and all the buildings are electrified with heat pumps, which I'll talk about. I've got some slides on that as well. Does it make sense to try and build highly efficient buildings to solve the climate change problem? I assert that it doesn't as much. You build comfortable buildings, you power them with solar power with renewable electricity from the grid, and you create heating and cooling with electrical appliances, and everybody wins. And so the only argument for efficiency then becomes one of economics, which is not a social concern. It's a concern for the developers and the tenants of the building. It's a separation of the concerns. And I think we've reached this cusp point in a really interesting point. Two more points on this just to set the thesis.
Let me get my head clear. When you're talking about efficiency, you're distinguishing that from what? Efficiency to me means anything that saves energy. But
Yep.
you're distinguishing efficiency from what?
No, I'm saying that a lot of our efforts, and this chart is very focused on building efficiency, of making passive buildings that require less energy to heat and cool.
Right.
And I'm saying that if the energy that's used is very, very low carbon, and it's being used in electrical appliances, building efficiency doesn't matter. Tenant comfort and economics matter, but it stops being a climate argument and starts being an economic and tenant comfort argument. All right.
Okay.
Next, just two more points in the thesis.
Mm-hmm.
That means that in new buildings, what we care about is embodied carbon more than building efficiency, in my opinion. Embodied carbon, cement is 8% to 10% of our total global greenhouse gas emissions. It is sand mined for cement aggregate is the single biggest mining process in the world. And that means that the cement used in standard cement buildings, especially multi-story buildings, is actually one of the biggest carbon debts that's impossible to repay for buildings. And so that's where my focus is. So engineered hardwood construction, which Canada is a leader in, along with Scandinavia, is one of my key focus areas. The last point I make is that means we have to pay it. I'm very concerned about the legacy of existing building stock. We have a lot more buildings that are already built than we're building new. And so I'm very concerned about what we do with the buildings that we already have, and about making sure the buildings we build have no carbon debt. So that's my thesis. It was triggered by this. I published a series of articles on that. It led to a bunch of discussion, and it had some changes. We'll talk more about some of these other slides, but I think that's my thesis. That's where I kind of wanted to start sharing with them, start the conversation with Paul. Mm-hmm. And I've given him like lots of room for to react to.
Good. Okay. Is this you guys going to go toe to toe, or do you agree already?
Well, thank you so much for launching that thesis, Michael. And I think we will we will thoroughly disappoint the viewers and listeners in that we're not going to have an argument on this. I am 110% in agreement with you on this. So let's see if I can just share a slide to talk around a little bit.
Yeah, certainly one of the things I'm looking forward to is getting more nuance around some of these points. Paul is a professional who spends his time in exactly this domain. I skim across the surface and go deep with my nerdy knowledge into domains, but I'm not an expert like Paul is in this space.
All right, for reasons that I can't quite figure. Oh, there we go. We might get the image now.
6 points. All right.
Come on, you can do it. I know you can.
You know, the blessing of this is,
I think it's emerged behind it in your preview as opposed to in mail. So it would open up in a different application. So I think you want to close that down and find the other application, other window to share.
Okay, are you seeing that now?
Nope.
no.
Okay.
You might want to stop sharing, share your entire screen. That would be a simple way to do it.
I'll do that.
You know, the blessing of Zoom is, although this is going live and a few people will be watching it now, in general, the nice thing is I can edit out anything where we have to waste time like this.
All right, terrific. Okay. So to sort of build around your thesis there, Michael, you are absolutely right. Although the image of this new house, looking very typically suburban, as it does, so it's got all those things against what you were just speaking about. It's not urban. It is a large house on a large suburban lot. It's all those things. And it's proudly displaying that it's got an 87% energy reduction. And this is a project that my firm completed a couple of years ago. And to your point, I feel exactly the same way. Energy efficiency is not the target. Reducing greenhouse gas emissions is our target. So greenhouse gas emissions efficiency should actually be our target. And I've generally found that the energy efficiency and having that as a target is language that grew out of the 1970s and the oil crisis and all of that thinking. And our governments and other thought leaders picked up that language and recycled it into climate change. It partly fit, because here in Ontario, the majority of our buildings are heated with natural gas. And so if we reduce the heating load of the building, the heating of space and the heating of water, then we, by inference, reduce the amount of natural gas that we're using, which will in turn reduce the amount of greenhouse gas emissions into the atmosphere. So it's a chain that actually works relatively well in Ontario, but it doesn't make sense. And it also, I think, confuses the marketplace. It confuses the public. The public don't know what the real target is. And I've personally started a language of changing energy efficiency and NRCan certified energy advisors. I've started changing that language to changing energy to emissions, because that's really what the target is. So some of the things that were built into this house were, the client knew that they had available to them natural gas to heat their house and to heat their water, but they didn't want to do any of that. They wanted to electrify everything in their house, and they did. They have air source heat pump for space heating. They have an air source heat pump for water heating, and they even have a condensing dryer so that they don't need to put that dryer vent out of the house, so that any heat that is created by the dryer stays within the envelope of the house in the wintertime, but gets ejected in the summertime. And so they were also then very careful at looking at the embodied carbon. So this house is built entirely out of wood products. So wood structure, wood cladding. I should say almost all of this house is built out of wood. We ended up using rock wool as the insulation, which was sort of the closest low carbon that we could get to available in the marketplace at the time. If we were to build this house in Ontario right now, we would replace all of that rock wool insulation on the exterior. We would replace that with mineral fiber, or rather wood fiber insulation. So, a complete or as close to no carbon in the wood fiber insulation as possible. So the only concrete that was used in this house was for the foundation. And we could have, according to the Ontario Building Code, we could have built the foundations with permanent wood or preserved wood foundations. And we pitched that at the client, and the structural engineer was all on board with it. But the client felt that was one step slightly too far. They backed off on that a little bit. And
Can I interrupt with a stupid question? All the houses when I first moved to Canada, I remember noticing that every house seemed to be made of brick or stone. And I asked about it, and they said, oh, there was a big fire 100 years ago or something. And they made a law that every house had to be made of either brick or stone or something like that, and not wood. I don't know whether that's still the case or not, but obviously you managed to build a wooden house. Is there any limitation on the use of wood for construction?
Yes, Meta, there's limitations about the distance between buildings. So when buildings get closer together, it's been proven that a side window in a house, when the house is on fire, it's consuming all of the oxygen within the house. Eventually, the fire in the house gets hot enough that it breaks the window cracks. There's a rush of fresh air full of new oxygen comes in the window, feeds the fire, and the fire leaps out the window. Fire will only leap 8 feet. That's why there is generally a 4 foot from the property line minimum in new construction. And very suburban construction. But as Michael would say, that is not an urban strategy at all. And then we would, so when we have enough distance, we can build with wood. There are other ways of getting that fire protection without brick as well. So just to wrap up this, one other thing that Michael spoke about is our existing buildings and taking care of those. And although this is new construction, the majority of the work that my firm does is retrofits. And I know from a solving climate change, or dealing with climate change, we have to deal with the existing buildings. 95% of the building stock, which is going to exist in 2050, is already here today. And so we need to retrofit those buildings. And I take the learnings from these new types of buildings and say, if we are going to retrofit these buildings, we are going to look very closely at the embodied carbon that we're using for the materials to retrofit the buildings, because like investing in your RSP, the earlier you do it in your life, the greater the impact. And exactly the same with carbon. When carbon gets emitted through the extraction and manufacture of the building materials versus when carbon gets emitted through the operation of the building, that building material carbon in the beginning, that has a greater impact. And certainly if we are targeting staying below 1.5 degrees Celsius by 2050, then we need to be taking care of that carbon right now. So there you go. Disappointed everybody. I completely agreed with Michael on all points.
Except I'm going to disagree with him slightly. So
Okay.
we'll have some tiny conflict, but it'll be hopefully intelligent and nuanced conflict that's interesting, as opposed to, oh, I hate this and you hate that, and therefore we will never disagree. It's just bad TV, I think. But okay, so statement one, you talked about Rockwool. Oddly, I've actually spoken to senior executives in a Rockwool manufacturing and distribution organization and gone deep on home insulation and residential and commercial insulation because I'm a nerd, as Meta discovered a couple of weeks ago. And the interesting thing about Rockwool is that it is fireproof. It doesn't burn. It also does not have the same. It also does not have the same problem that cellulose blown insulation has in terms of, which is flammable, more flammable. It also doesn't have the same problem with accruing mold as fibrous insulation. And this becomes to Paul's point about the St. James thing. One of the things that I got to do last year was work with NRCan, Natural Resources Canada, who Paul mentioned, to bring leading practices for retreat in the face of climate risks to help build a municipal leaders guide for Canadian municipalities. We in Canada, of course, have every climate risk, from permafrost thawing to flooding to wildfire to extreme weather to sea level rise. We get it all. We're so big, we have every single climate risk going. And so as I started thinking through the Rockwool versus other things, Rockwool is actually, to Paul's point, a very good product as an insulating product, very low embodied carbon. But it also has other benefits for resilient architecture that in places that are flooded periodically. It's like a sump pump. If I was in a floodplain and I was adapting to living in a floodplain with certain classes of floodable architecture, I'd be putting Rockwool in instead of the other stuff. If I was living in a humid place, I'd be putting in Rockwool to avoid some of those other types of things. But I want to extend one of the points about fireproofing. One of the things.
Excuse me, but you said you're going to disagree, but it sounded like you agreed. Rockwool is good. He'd used Rockwool.
But he wants to use something else.
I was saying that I was something else, but he used Rockwool.
If he was to do it again, he would use something else. And I'm saying, I like Rockwool. Rockwool's just fine. And it has some other advantages he didn't mention.
Got it.
Minor disappointment.
And we're not disagreeing there. In actual fact, I do know about Rockwool. All of Rockwool's other great properties, have used it for years. I think the point I was trying to make there was, if I was driving the carbon down further, the embodied carbon, I would use wood fiber instead of Rockwool. It is now the only possibility that is lower carbon, but doesn't have a lot of the other benefits. You're absolutely right.
And this is a fundamental.
Excuse me, but doesn't this issue of flammability would be on my mind a lot? And you had in our first conversation, Paul, you had to convince me that mass timber was a good thing.
Yes.
Because I was afraid of fire. But I would be even more afraid. You'd have to work harder to convince me that wood shavings or whatever it is you want to use would be a good form of insulation. That sounds to me very flammable. No?
And again, here's the sort of unfortunate. In order to make the wood fiber insulation and the cellulose insulation, which is basically newsprint churned up, for lack of a better term, in order to make that non-flammable, they add in a lot of borate, which is a chemical, which has concerns. Mm. So almost nothing that we as humans have devised yet is benign. We do not have the brilliance of whoever designed that wonderful piece of nanotechnology that Michael talked about on your last chat, the tree. None of us have come up with anything as good as a tree yet, not even close.
Okay. But to the point, everything is a compromise, and I live and ascribe to the pragmatic assertion that the perfect is the enemy of the good enough. Rockwool has many beneficial characteristics. Borate infused, wood fiber insulation has excellent properties, and it's a choice. And when we're talking about, decarbonizing our building stock, we make many compromises as we move forward. I'd like to lean on a little bit the disparity for natural gas and things across the country. I've got some charts on that. I'll try to skim through them fairly quickly. So one of the key things I always go back to is that all of Canada is not the same. Now, this is the intensity of greenhouse gas emissions for electricity as of 2016 on provincial grids. So you see BC's at 12.9 grams of CO2 per kilowatt hour. And, we as Canadians, average household is a bit over 10 megawatt hours of electricity. So, that, as we discussed last week, Meta, that turns into some carbon that you use just for consuming electricity. But next door in Alberta, as of 2016, it's better now and it's going to be much better over time, is vastly higher than that because they still are burning coal and gas. But then we look at
the discrepancy there is enormous.
And you look at Manitoba and Quebec, and they're vastly lower than British Columbia because of their hydroelectric reserves. And so you go back into Nova Scotia with its 600 grams. That's evidence that they still have a lot of coal on the grid. So one of the things that turns into is a significant variance as we consider gas versus heat pumps across the country, according to those numbers. Now, this is projected forward to 2030, when the current carbon price hits $170 Canadian per ton, about 133 Canadian US. Now, what I've done is I said, if you have a building, an average building, and you are heating it with a gas furnace and you replace it with a heat pump, what is the value proposition of that, both from a cost perspective and from a carbon intensity perspective? And so this is the grid electricity thing. You can see that BC, you save a lot of carbon. You save 50 tons of carbon a year per my model, whereas you actually, because the grid electricity is so much higher in CO2, if we take 2016 grid intensity in Alberta, which is already better, we actually have a higher emissions in Alberta if we put in a heat pump, in 2016, than if we left the gas furnace and did an efficiency retrofit. And you can see some significant variances across here. Now you notice, the sharp-eyed observers will notice that I'm missing a couple of provinces. That's because they use oil furnaces, which are so vastly worse than gas furnaces in terms of greenhouse emissions and cost, that they just skewed this entire chart and made the thesis hard to understand. But
Michael, I don't know what question to ask you, but I haven't got it. I haven't quite absorbed what you're trying to say. Gas
furnaces are both in 2030 will both be vastly more expensive to operate in most provinces, and they'll be vastly higher CO2 emissions to operate than heat pumps.
Than what?
Heat pumps.
Than an air source heat pump, which is all electric.
Oh, I see. So now having this, what is good? Having a high, a high thing or a low thing? Here you have Alberta down under zero.
The high things are savings. This is savings.
Savings. Now, why is it that Alberta and Alberta in particular would not save anything? If that's a bad sign, what's wrong there again?
So Alberta doesn't save any CO2 emissions because their grid electricity is so high in CO2 emissions. Alberta doesn't save any money.
I see. So it's because they're using electricity, and the electricity is using fossil fuel.
Yes. But as the grid decarbonizes, that number changes radically. I've projected out that Alberta will be down around 200 grams of CO2e per kilowatt hour, down in the range of New Brunswick by 2030 with the carbon price, simply because they'll be displacing gas and coal, wind and solar. But the other point is, why is the cost? Why aren't they saving any money? Well, that's because Alberta and Saskatchewan have fossil fuel generated electricity. And the theory of that is that it's cheap, except their retail prices of electricity are by far the highest in the country. They're 17 and 18 cents per kilowatt hour for every kilowatt hour consumed, compared to 5 to 7 cents in Quebec, 12 cents in Ontario. And so the same amount of heating requirement or cooling requirement costs a lot more with electricity than it does with natural gas in those provinces, despite the increase of $8.50 per gigajoule with the carbon price of $170. And Paul, that's a good number for you. For those people considering gas furnaces, you can say 2130 every gigajoule, 850 extra.
Mm-hmm.
Right. And that's how it's measured, and build and stuff like that. So
$8. Sorry, explain. 850. What? What's that?
$8.50. So a gigajoule is a measurement of energy in natural gas. It's how it's billed. And the carbon price adds $8.50 to every gigajoule. Paul, you probably know, I've forgotten how many the average home uses in a gas furnace.
About 900, I think.
900 per year. So that's 900 gigajoules a year times $8.50. So that's thousands of dollars a year of additional cost for natural gas due to the carbon price, which is exactly what we want to see, because it incents the behavior to replace them with heat pumps. As you can see from this chart, even at 2016 grid emissions, with 2030 carbon price, there's no fiscal case for keeping your gas furnace. You want to get rid of that operational cost and transition to an air source heat pump as soon as possible. And then we save a whole bunch of money. I won't show it that card, but this is the chart that gets to my thesis. What I did is I went across here and said, if we just did a building efficiency retrofit versus a heat pump retrofit, which saves the building owner more money? And as you can see, it's only in Quebec that a heat pump retrofit actually saves the building owner as much money as an efficiency retrofit. And so we want to change everything to carbon. The best way we want to decarbonize everything, that's heat pumps. That's the right choice there. But the building owners are incented fiscally by efficiency, not to put in heat pumps. So we have a gap that we have to bridge. And that's a fundamental policy challenge, which is why I'm kind of pushing this with as much as I can from my small position of whatever influence I have as an author, to assert that our policy should shift.
You got to make me smart now. I'm not going to let you go past where I can sort of follow you, but I don't understand why, unless you're saying that some heat pumps are not actually using electricity. But
Paul, why don't you explain this one?
I'll give it my best try. So thanks, Michael. So what the top red line is showing is your cost savings if you retrofit your house to make it more airtight and better insulated, to save on the costs of heating and cooling your house. That's sort of your return on that. The blue line shows if you did not do any of that efficiency retrofit to your house, but you just swapped out your gas furnace for an electric heat pump, then what would your savings be in these different provinces? And as Michael has pointed out, it's only in the province of Quebec that those two lines come close together, virtually the same thing. Everywhere else is a delta in that spread. So the homeowner is incented financially to retrofit their home and to save on energy. And whereas, as Michael says, our target being to decarbonize, to reduce the amount of greenhouse gases that we put into the atmosphere, the heat pump strategy gets us there a lot better because we take away our natural gas burning appliances. However, the financial incentive isn't there, and that's the delta, that's the gap that Michael was referring to. Okay. Did I get that more or less correct, Michael?
Absolutely right.
And what do you have to do to change that motivation?
I'll start, and I'm sure Paul has some insights. I'll just talk about British Columbia. I happen to live in a pocket of the future. And, as William Gibson says, the future is already here. It's just unevenly distributed. And I happen to live in part of the uneven distribution around many things. And so here, if for a commercial retrofit of a building, you can get a provincial grant of up to $200,000 for including heat pumps. So the building can do an efficiency retrofit, an envelope retrofit, replace its windows, replace its gas furnace with heat pumps, and get $200,000 to make the case for that fiscally viable, and potentially to do it outside of larger renovation cycles. So that's advantageous. The second one, the city of Vancouver has declared a climate emergency, and they have a 64-point plan of actions. One of those is natural gas. They will no longer approve major retrofits or new building with natural gas heating inside the boundaries of Vancouver. And that's Vancouver, the city, not Metro Vancouver, because Vancouver, the city, is about 700,000. Metro Vancouver is about 2.6 million. We have a small but very rich, densely populated place. And we have Surrey, right? We have 24 different municipalities and voting districts. Vancouver has made that point. So we've done that. The second thing that Vancouver itself has done, in addition to saying no more natural gas, is they have created a regulatory accelerator program for heat pumps. So if you're doing, and Paul lives with this, he has to do regulatory approval processes with City Hall and put in lots of paperwork and stuff in his programs. If you put in heat pumps, it's a fast check mark. If you put in anything but heat pumps, you have to explain it to them, and you have to go through more paperwork and stuff like that. You put in natural gas, you're not even getting it approved, right? And so that creates a regulatory accelerator for one, a regulatory burden on the other. Some people will get exceptions, but they have to really fight for the exception. And people do, developers do, and architects will do what is easier, because time is money, and the money part is taken care of by the province. So that provides a pattern. Funding for the investment from the federal government and the provinces, incentives to, and we need to focus those incentives not on efficiency, but on fuel replacement. Last point I'll make is an Ontario point before Paul takes over and provides his context. Bruce Hanson is an efficiency engineer I've spoken to many times over the years. Had a great coffee with him in, God, I've forgotten the name of the neighborhood, just on the other side of the Don River.
Riverdale.
Riverdale. I was thinking that can't be right. That's a TV show. But had a great coffee with him. He spent much of his career working with provincial efficiency programs and was blind to fuel replacement because the Ontario government's programs did not incent fuel replacement. They only incented efficiencies. So we have to adjust provincial incentive programs for fuel replacement over efficiency, because building owners and tenants benefit from efficiency, but they'll, and that's a business case they should make, but the social case is for carbon.
Now, let me make sure I've got you. What you're saying is that Vancouver has gotten smart and has put in these new changes, which you approve of, but it's not reflected yet in this chart we see yet, but will be. Am I inferring the right thing from what you've been saying?
Correct. This is the operational cost view, not the transformational cost view. Paul lives in the transformational cost view and has to project the operational cost view. This is the operational cost view. And to be clear, homeowners are weird because they're individuals. They make irrational decisions more often than businesses, because businesses spend more time in spreadsheets. And so, Kahneman talks about system 1 and system 2 thinking. Most decisions by most homeowners are made in fast system 1 thinking. Most decisions by businesses are pushed into slower, more methodical system 2 thinking. And so, I'm a spreadsheet junkie. I force my brain into system 2 all the time, but I'm irrational as well. Paul, why don't you I'm going to stop sharing because I think I've shared enough. And what do you give your perspective on those incentive thoughts and the funding thoughts and the operational versus transformative cost thoughts?
Yeah, thanks so much, Michael. So here in Toronto, Ontario, we are a few steps behind Vancouver, BC. Yes, we have declared a climate emergency, but we haven't put in place any of the other things that Vancouver and BC have put in place. City Hall, certainly Toronto City Hall is looking through a program called Transform TO at the methods that they would use, and we're looking very closely at Vancouver. Whether the provincial government of Ontario is looking at anything is an open question. So I'll just leave that alone for the moment.
I won't. They canceled the efficiency program at the provincial level as one of their first activities upon entering stuff, along with 758 renewables contracts. Paul has to live in that province. I can be a gadfly.
You can be a gadfly. Thank you for bringing that up. You're absolutely correct. And so that's the climate that we're working in here in Ontario. As an individual, I want to do things. Most of the people that I connect with here in my neighborhood called the Pocket, which is a piece of Riverdale. I know Mr. Hanson very well. Yeah, he's a neighbor.
So that means you have to put up with his bicycling stuff even more than I do on Facebook.
Yep, absolutely. And community meetings, et cetera, et cetera. And so, we're all wanting to do things. The city of Toronto, they're wanting to do things. We have this archaic system in Canada where the cities are children of the province. The city has to go to the province to get permission to do things. It's mind-boggling. And that's where we sit in Ontario. So if anybody's wondering why Ontario is lagging behind, that's one of the primary reasons right there. However, most of my clients, and I'm now working with the other Pocket residents, I'm the retrofit coach in the Pocket, and I'm trying to convince people, first of all, why it's a good thing to do. What is the real target? It's carbon emissions, greenhouse gas emissions, rather than energy efficiency. And how do we do it? How do we get there? And I'm convincing people to, yes, retrofit your homes, because we live in 100-year-old, very leaky, very poorly insulated homes. Well, there's not a lot of point about just slapping an air source heat pump on that. It will work, and it actually won't cost you. We do have a few examples in the Pocket where people have replaced a now defunct natural gas furnace with an air source heat pump, and it has not cost them any more, even though electricity is more expensive than natural gas. The air source heat pump is 3 times as efficient, has a coefficient of efficiency or a performance rather of 3 or greater. And so, cost-wise, they're using a lot less units of electrical energy than they would be using units of natural gas energy. And so from the homeowner's perspective, the cost, which is always the important thing to them, from the homeowner's perspective, they can now heat their drafty, uninsulated home with an air source heat pump for the same or slightly less cost than they were heating it for natural gas. So at least that's not a barrier to entry.
Yep.
Once they do that, and now I'm working with these Pocket residents, once they put in the air source heat pump and they realize how wonderfully this thing is working, I tell them, and the installer of the air source heat pump tells them, that now if you tighten up the air seal on your house and add some insulation, this thing is going to work way better. Like it'll take it from working good to working great. And that, even though I try to preach, seal up your building envelope, insulate it better first, then fuel switch, if you do it the other way around, so long as you do both, doesn't matter the order you do them in.
But to be clear, if you do the fuel switch first, you start saving the carbon emissions incredibly rapidly.
Exactly. Yeah.
And I do want to disambiguate one thing. We keep talking about air source heat pumps because there's also water source and ground source heat pumps. So, down in downtown Toronto, they have,
Deep lake water cooling system.
yeah, what's the name of that company again?
Enwave.
Enwave, thank you. It slipped my mind. I'm much better with numbers, remembering numbers than I am with names.
Not a
But
problem.
Enwave runs a pipe into Lake Ontario, a few dozens or 100 feet down, where the water is always the same temperature. And all a heat pump does is it moves heat from one place to another based upon a differential. It's just like an air conditioner. As a matter of fact, it's incredibly similar to that. All an air conditioner does is move heat from inside your house to outside of your house. And so a heat pump is moving heat from outside of your house to inside of your house. And that coefficient of performance, that 3 times, means all you're doing is moving that heat. So you get 3 times as much heating or cooling for the same electricity. Instead of a baseboard heater where you get 1 unit of heat for 1 unit of electricity.
Okay, let me see if I'm getting it. So there are 2 factors involved. One is you're switching from gas, fossil fuel to electricity, which is presumably better. I mean, I have questions about things like.
It depends which province. Province you're in.
But okay. So you're switching, theoretically, when you switch to a heat pump, you're switching to electricity, which, let's say, is better, although I don't know whether it's always better. But then the other thing is the heat pump itself as a mechanism is more efficient than
baseboard heaters, for example.
Okay, so you're getting two sources of improvement with this heat pump. Whether or not it's a water pumped, air developed, or whatever, does it matter whether it's from water or air? Or
it does for 2 reasons. The colder, it works better with more temperature difference, and so when it's really cold outside, the heat pump struggles more to extract the lower degree of heat to bring it in. Now in Toronto, it's not a problem. In the prairies, it's more of a problem. But to Paul's point about the building he pointed out, the house he pointed out, they're doing capture of the dryer vent heat. And it's also possible to capture the heat off of the water that flows out of the house. Here in British Columbia, in Vancouver, Olympic Village, just over here, 2 kilometers from where I live, master planned by Scott Hine, who Paul probably knows the name of. Urban planner in British Columbia, in Vancouver for years, and coming out with a big book, by the way, Paul. So probably want to look for Scott's book that's coming out. But Scott Hine, I was on a bike tour with him, and we were talking about the plant for district heating in Olympic Village. What they do is all the water that flows out of the condos and apartments and social housing goes down into this heat reclamation facility, and they capture the heat using heat pumps, and then they turn that heat back and push it back into the buildings to provide that heat. So capturing the heat that we normally throw out through our doors, our windows, and our sewer pipes and our, is a mechanism that immediately starts to enhance that. But those are follow-ons. Those are comfort features more than stuff. I do want to add 1 point. So water source, easier because if you've got a big water source. Ground source, you put in trenches and you put pipe, tubing in, and you do that, or you drill down. And you've got ground below 6 feet. The ground is always the same temperature, as long as you're not in permafrost land. And so you get greater differential. It's just more capital cost to put in those systems. Air source makes much more sense for residential. The bigger the building, the more likely it is that ground source or water source heat pumps start to make sense. There's a building over on the other side of Spadina from, Paul, the other side of Toronto and the other side of Spadina, across from the old Globe and Mail building on that little street there with that amazing bistro. Serves an amazing cassoulet. I forget the name of it though, because I'm bad with names.
There's a lot of amazing bistros over there. You're gonna have to narrow that down for me.
I know. They used to be on Queen Street, but now then they moved down.
I'm also wondering which side of
Oh.
of the town you're talking about, because the Globe and Mail, moved and they tore
the
down
old
their old
location.
building.
Yeah,
So if
yeah,
you're out
yeah.
of date, I
No,
don't
no,
know
it's
which side
the
of
old
town.
location.
I
The old-
think it's a building on Wellington Street, I think.
Wellington, that's it.
Yeah.
So there's Wellington, there's a luxury residential building of 8 stories, 12 stories, and it's ground source heat pumped, heated and cooled. So they've did that piece. Last point I want to make though is Paul was talking about it's always better to do those other things. One of the things I did was a really interesting assessment for Canada specifically of taking the worst 10% of our commercial buildings. We've got about 50,000 commercial buildings, and the average commercial building is about 5,000 square feet. They're not big, right? And so what I said is, I'm going to make some assumptions about that average commercial building, that 10% of the worst ones. They leak, they have big holes, lots of draft, they're run on gas furnaces where they have air conditioning. It's rattle trap, old, highly leaky air conditioners. What if we just took the bottom 10% of buildings, of those commercial buildings, and just did nothing but put heat pumps in? You'd probably get the same comfort for the people internal to the building, because leaky buildings have comfort and draft problems regardless. But what I found was just doing that intervention on that small 5,000 set of buildings across Canada would achieve 1% of our total greenhouse gas emissions reduction targets for Canada for 2030. Just one intervention on the worst small commercial buildings, 1% of our total greenhouse gas targets for Canada for 2030. So this is a big deal, right? We have to get the policy right.
Make an intervention, a legal intervention, or something more than just saying you'll save money. Could you do something like, damn it, you got to do this kind of thing?
Well, that's what Vancouver has done. Vancouver said, when your boiler ages out, you don't get to put in a new one. When you're renovating, you don't get to keep gas, right? That's the direction it's going.
Yeah, to tag back to something you also said in your last chat with Meta, Michael, which I absolutely loved, is that we're up against the barrier of human nature, and we've tried. We basically, our incentives, we have carrots and we have sticks. It's all we have, all we've ever had, and we've tried carrots somewhat, and they don't generally work. We now need to incent by making it law, as Vancouver has. And I know exactly the buildings that you're talking about. These are the kind that, ring the airport, and they're those 2 stories of office on the front and a big warehousey space at the back. I mean, there are hundreds of thousands of these things across Canada, and they haven't given one iota's thought to energy efficiency or carbon efficiency or human comfort or anything. The only thought they gave was build it as cheaply as legally possible, and even the legal part's negotiable.
Look, we don't have that much time, and I want to have 2 different topics. At least I want you to explain cement to me more, concrete. That because you've convinced me that it's an important thing, but we haven't really touched on it. And I don't understand concrete and what's so bad, and what the opportunities are to improve the quality, or the stop making it such a terrible thing. Is there any way to make good cement?
I've published on this and read the literature, and I've talked to experts on this. So I'll start, and Paul will undoubtedly have some add-ons. So cement, I'm just going to say reinforced concrete has been a tremendous boon to the world in terms of the architectural forms it enables us to create, and the buildings which we can create to do new and amazing things. I love mid-century architecture buildings. They weren't possible without engineered concrete for the most part. This is not being against cement or concrete. This is saying we have to reduce our use of it, and we have to make it better. But cement itself, concrete is cement plus aggregate plus water. You mix them together, you spread them out, and then they cure. And that's how that works, is a process of where they set. And we've, many of us have seen that, and seen people who've put their feet in cement before it's cured, and then you get this footprint preserved Most recent funny one I saw was a bunch of ducks walked across the cement before it set. So there's duck prints forever embodied in the concrete. But cement and the aggregate are significant problems. The cement itself comes, is a combination of clay and quicklime and a couple of other things. And the way they get quicklime is really interesting. They dig up limestone in massive limestone quarries. They truck it to a cement plant. They crush it. They put it in a cement kiln. So that's a bunch of diesel that's used for digging it up, a bunch of diesel that's used for transporting it. The cement kiln is fired typically by natural gas. So lots of fossil fuels used to heat up the limestone. The limestone then emits, as a chemical process when introduced to heat, CO2. Lots of CO2 bakes off of the limestone as it turns into quicklime. So you've got the natural gas emitting CO2, you've got the limestone emitting CO2 as it turns into quicklime. Then you put the clay and the limes and the cement and the quicklime in this cement kiln, the rotating, 130-meter drum with a 30-foot jet of natural gas blowing up through the middle of it, and you rotate it to tumble the cement, the quicklime, and the clay together to create clinker and cement. And you take that out and you crush it into powder and you put it into these very heavy sacks. And then you distribute the sacks using diesel trucks to building sites. And so what you've got is lots of natural gas emissions from all the mining, distribution, quicklime, cement kiln, distribution, and some of those, a bunch of those can be diminished. Like electric trucks and electric mining equipment, both of which are present and emerging in spaces and are going to be dominant, eliminate most of the mining and distribution concerns. We can do electric heat for the cement kilns. We used to have one in Nova Scotia, I think it was, or New Brunswick or Newfoundland, one of the ends out in the Maritimes. We used to actually have an electric cement plant. We can actually have sources of heat, so we don't burn the natural gas. But when we bake, we still don't have a replacement for quicklime that's low CO2. We have to do something about that right now. And then there's the aggregate. Remember I mentioned it's, the biggest thing we mine sand and aggregate for cement. It's the single biggest mined product in the world. There's 50 billion tons a year, I think is the number. It's just absurd. And all of that has a CO2 footprint as well. And so we have to do something about the aggregate. We have to do something about the cement. We have to capture the CO2 that comes off the quicklime. It's non-trivial and it's in everything. If you look out your windows, to Paul's point, the foundations are cement, our sidewalks are cement, most of the tall buildings are cement, the overpass down on the waterfront that's blocking your view of the lake is cement, right? It's everywhere. It's the glue, the gray glue that holds our society together.
And you don't see more than just being able to replace a fraction of the sources of CO2 in this whole thing.
You can decarbonize a whole bunch of it. It's non-trivial to get to the last. That's one of the few places I say we'll probably still need carbon capture and sequestration is on the CO2 that comes off the lime kiln. Everything else we can decarbonize in that process, but the CO2 that comes off the cement in the limestone in the lime kiln as it turns into quicklime, that stuff we have to capture and sequester or do something with. It's still a lot.
You're suggesting capturing it right at source rather than talking about things like counting on trees to do it for you.
Correct. This is one of the at source emissions things we have to fix.
Okay. Well, I don't know whether to be happy or sad. It sounds like you made a little progress, but I'm not too clear.
No,
I know
we know what we need to do.
Is.
We know what we need to do, but it's really hard to get it done.
Yeah, but Paul once had a wonderful conversation about mass timber. Mm-hmm. So I've been convinced by that, although I remain, ambivalent a little bit. Go on, Paul. Are you still on to mass timber as the best solution or not?
It certainly a very good solution at the moment. It certainly replaces a lot of that above grade concrete. And the nuance, as well as, personally, if I had to work in an office and I was surrounded by wood versus surrounded by concrete, I'd be a lot happier in a wood office. So to nuance a little bit of that great description that Michael gave of the production of concrete, he's absolutely right. Concrete in and of itself is not the problem. It is the production of the component parts and the actual component part of the quicklime. Those are the problems. So we can deal with the production issues mostly by electrifying what is currently done with fossil fuels. And again, back to Michael's earlier point, it then depends what province you're in, how good that fuel switch issue is. Much better in Quebec than it is in Alberta. So if we were electrifying things in Alberta, we'd still be putting out a lot of greenhouse gas emissions just for the production of the electricity.
But all grids are decarbonizing. So
Yes.
Anything we electrify gets more virtuous over time.
Gets better over time. Exactly. So it is the North Star to aim to. Absolutely. And there are a number of very clever engineers who are now working on ways to replace that quicklime. One early out of the gate solutions was using fly ash, and basically that they scrape down the inside of a chimney from a steel smelter. Okay, but to produce more of that, we have to smelt more steel. Maybe not driving in the right direction. Good thought, but maybe not encouraging the right behavior. Now, okay, we could smelt steel using electricity, but then oddly enough, we don't get the fly ash. So okay, well that avenue petered out a little bit. There's other companies around the world that are looking at different replacements. They're even going back to, hey, what did the Romans use? Because the Romans didn't use quicklime. The Romans used volcanic ash. Well, I mean, that was great for the Romans because they had that big volcano just down the road in Naples, just outside Naples. So okay, so that worked for the Romans. But we don't have enough volcanoes with enough volcanic ash to satisfy our hunger for the amount of concrete we need to produce. And I'm not suggesting that we encourage more volcanic eruptions. I don't think that's going to push us in the right direction of lack of greenhouse gas emissions either. So I'm thinking those volcanoes spew out quite a bit of greenhouse gas emissions all on their own. So that's also not driving us in the right direction. All that rambling to say, I don't really know what the answer is, but we have to find it. We have to isolate the problem, and we've isolated it down to the quicklime. That's at the moment the unsolvable problem, unless you've got another trick up your sleeve that I don't know about yet, Michael.
Well, there are actually solutions for this, and carbon capture at flue, and some carbon capture just for that component still makes sense. We have mechanisms for this. My biggest challenge with this is that none of the solutions we've come up with so far are economic. As a low priced, high other attributes, high quality product for construction, our entire economy shifts if we triple the price of it.
I'm going to have to call this to a halt. We're over time, and editing gets harder the longer we go over time. But I would say that sounds to me like there are several other types of construction material that we haven't even touched yet, and that I would love to have another conversation about at some point in time, if you guys are willing, steel and things like that. So can we come back to it another time?
Absolutely.
Yeah.
Perfect.
Terrific.
All right, bless your hearts. Thank you so much for this. It's been fascinating and really important, and I have to study hard to make sure I've followed you the whole time. Thanks a lot.
Paul, pleasure to meet you.
Likewise, Michael, pleasure to meet you. Thanks again, Meta. Lovely as always.
All right,
Thank you, Meta.
take care. Bye.
Take care.